Hey everyone, this is Dr. Walker. This is the first video in the series for College Physics 2. The specific video is called Electric Charges. So let me start off with a question. Did you know that if you rubbed a comb through your hair or on your sweater and then you put it near a very thin stream of water, that thin stream of water would be attracted to the comb? It would be deflected by the comb. Do you have any idea what this is about? Well, it all has to do with electric charges, which we're going to start talking about in this video. But if you have any specific ideas, please feel free to post them in the comments below. So the first thing that I'd like to talk about are properties of electric charges. It is well known that two types of charges exist: positive charges and negative charges. What this picture shows here, it shows two pluses that are repelling each other, two minuses that are also repelling each other, and then a plus and a minus that are attracting each other. What the picture is showing is that like charges repel and opposite charges attract. Let's go ahead and do a question. We have a picture here. We have ball 1 and 2 are being attracted to each other, and balls 2 and 3 are being repelled from each other. So which one do you think is a true statement? So go ahead and pause the video, read all the answer choices, and think about what's the correct answer. Let's take a look. The actual answer to this question is A. So we don't know if ball 1 has a positive or a negative charge, but we know that 1 and 2 must have opposite charge because they attract. So let's just pretend that ball 1 has a positive charge, which means that ball 2 would have a negative charge. Opposites attract. Then we look at balls 2 and 3, and if ball 2 has a negative charge, then ball 3 also has to have a negative charge because like charges repel. So based on this, we can see that balls 1 and 3 have opposite signs for their charge. Now, it could be that ball 1 had a negative charge, we don't know, but we can use the same logic, right? If ball 1 was negative, that means that ball 2 would be positive because opposites attract. And if ball 2 is positive, then ball 3 is positive because like charges repel. So no matter what the charge of ball 1, we still see that balls 1 and 3 have opposite signs for the charge. Let's look at the next slide here. We have a simple model of the atom. So what it's showing is the nucleus of the atom, which has a bunch of pluses because it has the protons in the nucleus, which are the positive charges. And then you see these loops here, and these are the electrons. Here they're labeled E minus, but this is a simple model of the atom. It's also called a planetary model. And it shows electrons orbiting the nucleus. It's a simplified model, but it works for us. So what's important to know about this model, first of all, is that the protons are in the nucleus and they are positive, while the electrons are orbiting the nucleus and they have a negative charge. The charge of both the electron and the proton, the actual amount of charge, is the same for both. The only difference is that the electron has the negative charge while the proton has the positive charge. But the actual amount of charge is 1.6 times 10 to the negative 19. The unit for charge is coulomb, and the abbreviation for coulomb is C. So you can see I have the units in parentheses here. This chart also gives us the mass of the electron and the proton. What we see here is that the proton is much more massive than the electron. It's about 2,000 times more massive than the electron. And finally, this chart shows us a little bit about the neutron, which the neutrons are also found in the nucleus, and they're neutral. They have no net charge, so their charge is 0, and they have the same mass as the proton. So you're definitely not going to have to memorize all of these numbers. They will be provided to you. But this is just a good introduction to our positive and negative charges and where they are found in the atoms. The next thing is about quantization of electric charges. So we just said that the electron and the proton both have the same amount of charge. So we could say the magnitude of the charge, right? The amount of the charge is the same. So that specific amount of charge is given a variable called E. So E has that value, 1.6 times 10 to the negative 19 coulombs, that we just saw in the previous table. So this value for E is always positive because it's the magnitude of the charge. So if you want to write down the charge of a proton, let's say Q of P, then that would be E. But if you wanted to write the charge of an electron, let's say Q of E minus, then the charge of the electron would be negative E, because the E itself is a positive number. This brings us to our first equation for this series, and this equation deals with the quantization of charges, and it tells us that charge takes values that are integral multiples of the fundamental charge. So what this means is that when something is charged, and we do use the letter Q for charge, then it can only be made up of a certain number of either electrons or protons, and that number is going to be an integer. So you could have an object that is charged with 5 electrons, for example, and then the n would be our integer here, and that would be 5. And then E would be the charge of one of these electrons. So you multiply the number of electrons times the charge of that electron, and that gives you the charge on that object. So in this equation, there is a plus and minus, and all you have to do, if your object is positively charged, then just choose the plus. If the object is negatively charged, then you choose the minus. So that's the only purpose of the plus and minus, because N and E are always positive numbers, but your object can have a positive or a negative charge, so you need that plus or minus in the front, and you just choose which one applies to the problem. We will do an example in the video that accompanies this lecture. The last thing I want to talk about was conservation of charge. This says that charge is always conserved. You cannot destroy or create charge. So this leads us to a question. If you rub a stick with, let's say, some fur, and let's say that after you rub it, that the stick now becomes negatively charged. Well, what has happened? Did you just create electrons on the stick? Well, according to the conservation of charge, you have not. So what has actually happened is that charge has transferred from the fur to the rod. So you can think about what is going to be the charge on this fur here. Feel free to put your answer in the comments. I hope you enjoyed this first video, and I will see you in the next video.